We've learnt about these 7 shapes, right? And it's kind of 7, kind of not, because some of them, well, many of them overlap, actually, right? For instance, we know that a rectangle is just a special kind of parallelogram. It's a parallelogram with one right angle. Once you put one in, all the rest of them turn into right angles, okay? In the same way we looked at most recently, for instance, that a rhombus is a special kind of kite, right? The kite's got the 2 pairs of equal signs, right? And if you make those 2 pairs equal to each other, then you get a rhombus, okay? So even though they're kind of like 7 classes, they overlap with each other, right? Now what we're going to do is we're going to put them all together and build one of these, because as you know, in real life, things don't always come up in nice, neat, categorized shapes. They'll be in combinations of those, which is why we spent a day, an exercise, looking at what happens when you put some of these shapes together. What was that called? When you have a shape that's made up of several other shapes put together. Remember? Starts with a C. Starts with a C. Composite shapes, right? So, composite shapes, a particular kind of composite shape, comes from building these things, okay? So I'm going to show you what they look like. So this is an example of a composite shape, okay? Here's the scenario. Suppose we want to measure out some kind of space like an oval, which ironically are almost never ovals, okay? Or like a patch of concrete or something like that, okay? So it's going to be some awkward shape like this, okay? Something like... hold on, put that in a little further, okay? So you've got some weirdo looking shape there, which clearly, like I suppose what you could do is, you could put like a big square around the whole thing, but it's not going to be very accurate, is it? There's going to be all kinds of bits missing, extra bits and so on. Right? So here's the way we're going to approach it. We're going to take this space, and here's like you starting in a corner, okay? And we're going to go into this space and build what's called an offset or a traverse survey, okay? Now, let's have a think about the name first, right? A traverse survey. Does anyone know what the word traverse, what does it mean? Any takers? Yeah.
Well, traversing in snow sports.
Yes.
Going along like a straight, a flat like thing.
Yeah, good. Okay, so the idea is that a flat thing. I'm sure that's the technical term. A more simple way to say it is basically you're crossing something. Okay, so you're crossing a snowfield, for instance. Okay, so to traverse this area, right, is to go from one end across to the other. Okay, so that's the first part of the traverse survey. That as you're going to walk across this, traversing is what you're doing. Okay, but the second part of it, the more useful part, is the offset part. An offset is when you have, here's a straight line. Okay, and then you measure distances away from that straight line. And those distances are the offsets, okay? So for instance, you might walk along up to here, okay? And then you see, all right, maybe there's like a landmark, like a tree or like a patch on the ground or something that's important, okay? So as you walk up to here, and this is where you'll need partners, okay? You stop here, all right? And you measure how far you've gone, and this is what you'll use. So these trundle wheels, you position the start at the bottom, and then as you go forward, it should click. If we go far enough. Hold on. Is this far enough? There you go. It's pretty soft, but when you're going and you're hearing a lot of these, you'll pick it up, okay? So it's gone around 1 meter and it clicks. So suppose you've walked from here to here and it's clicked. Let's pick a nice easy number. It's clicked 10 times, okay? So this distance up here is 10 meters, okay? You then stop. You get your friend to help you and you look off at right angles, okay? So this right angle thing is really important. And you send your friend off to walk over to this landmark that you found. Maybe that's a tree or something like that. It's part of the border here, okay? So your friend has walked all the way over here. They'll have a trundle wheel as well, okay? And they'll measure that distance. Suppose it's 8 meters, okay? And then you're going to keep on progressing up through this, okay? You're going to move further over here, okay? Suppose you've counted 10 clicks, and then by the time you get up to here, you've counted, I don't know, say 23 clicks, okay? So what's the distance from here to here? If I counted 10 up to here, and then the 23rd click, it'll be the difference, won't it? It'll be 13. Okay, so you got 13 meters here, right? And then you'll measure the offset in a different direction. So you'll send your friend off. We said that was a right angle, right? you'll send your friend off to this side, okay? And they'll take their trundle wheel and they'll click, 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 click. And they'll say, okay, maybe I got 20 clicks, okay? So I've got that distance. Now, after this is all completed, we're going to have the traverse line up here, and you're going to have a bunch of offsets going off like so, okay? Then you come back, okay? And what you can do is, if I take all of those lines, the straight lines that I've drawn, and I use them as the basis of a shape, okay? So now I've got this approximation with these straight lines of what the space is looking like, okay? What I'm going to do is I'm going to join all these up. I've got this shape here, which is a triangle. I've got this shape here, which is it's a trapezium, because all of these are coming off at right angles. They're all parallel to each other. I've got another triangle along the end here, and then I'm going to complete the shape like so. All right? So this is the offset survey, or the traverse survey. They're both called the same thing. Okay? So you're going to go out and you're going to measure these. Now, let me put a few more numbers on this, because there's a particular way that offsets are actually measured out, because it's a bit of a pain to draw this whole thing. Okay, so let me just put some measurements here. I said that was 13, right? Let's suppose you've got like 5 meters here. Let's call that distance maybe 12 meters, 7 meters. And let's put in 2 final measurements. Okay. Okay, so here's how I would like you, as you go out there with your trundle wheel and a bit of paper and some friends, right? I want you to draw out 3 columns, okay? And here's how it's going to work. We're going to imagine ourselves, again, walking from the bottom up to the top, walking forward, okay? So your starting point is 0, okay? And then as you go through this, you're going to fill in all of the distances until you get to the total, right? So you're counting clicks. We counted to 10 clicks. And then you measured an offset to the left, okay? And the offset was 8 meters, okay? Then you kept on going. Now, for reasons that, I don't know, I guess it's because you want to get a total and these people are doing different jobs, okay? All the numbers up here are going to be the progressive numbers, right? So you remember at this point I said we had counted 23 clicks. So this next number will be 23. And then you stop and you measured an offset in the other direction, and it was 20, like so. Can you see how I'm building this diagram? How will the rest of it look out? What will be the total number of clicks when I get to this next point here? 28, good. And then you take an offset to the left. You keep going, what will be the number of clicks? 31, and then you take an offset to the right, and then you take your final one, which is going to make you 2 meters forward, right? So now you can see this the traversal, right, is 33 meters across, and then you've got all of these bits of information which you can build this shape off and then work out its area, okay? Clearly, the more times you stop and take a measurement, the more accurate it will be, but it will obviously take you longer, okay?